So the topic for the paper slide video is displacement versus distance. So first we're going to talk about displacement. Displacement is the vector distance from the initial point to the final point. So in other words, we're trying to measure how far away an object is from its starting point. We can use this to find the distance from an object starting to an ending point. So the formula to find displacement is the integral from a to b of your velocity function, dt. So we're going to do it from point A to B. Point A and B will be time. And if we put in a velocity function into this integral, we should be able to solve for displacement. So an example problem we have is the velocity of an object traveling on a straight line is given by v is equal to sine pi over 3t meters per second from 0 to 6. Find the displacement of the object for the given interval. So we have the graph of the velocity function, and the shaded areas are what we're trying to integrate, and if we solve for this area, we should be able to find the total displacement. And we have to keep in mind that the displacement can be positive or negative, depending on direction of velocity.
So to solve this example problem, we put the function sine of pi over 3t into the integral. So we get integral from 0 to 6 of sine of pi over 3t dt. If you solve this on your calculator, you'll get 0 meters. So the displacement of the object from t equals 0 to t equals 6 equals 0 meters. Here we have an illustration of the object. It would go to the right 1.91 meters and then back 1.91 meters. So its starting and ending position would be the same. That's why it's 0 meters. For distance traveled, this is a scalar quantity that refers to how much ground an object has covered during its motion. Another phrase for distance traveled is total distance. So distance traveled, the formula for it looks similar to the displacement formula, except we'd add an absolute value around the velocity function. So it would be the integral from a to b of the absolute value of the velocity function. And this is the total distance traveled from point A to point B.
All right, so the example problem for distance traveled is the same as the example problem for displacement. The velocity of an object traveling on a straight line is given by velocity equals sine of pi over 3t meters per second from t equals 0 to t equals 6. And we're asked to find the total distance traveled by the object on the given interval. And we have the same graph, same velocity function graph, except the shaded region this time, instead of the integral of the velocity function, we have the shaded region of the integral of the positive function part of the graph. And then when the graph goes negative, we've traced an imaginary line reflecting it over the y-axis so that we're integrating over positive again. So it's a little bit more complicated of a process to solve distance traveled. We put the velocity function into the integral again, so we get integral from 0 to 6 of the absolute value of sine of pi over 3t dt. And if you're solving with your calculator, you can just put that in. But if you're solving by hand, then you need to split up the integral. So you can do the integral from 0 to 3 of sine of pi over 3t dt plus the integral from 3 to 6 of negative sine of pi over 3 dt. And what that does is you're adding the positive part of the graph, and then you're adding the opposite of the negative part of the graph, which makes that positive as well. And you get 3.82 meters. So the total distance traveled by the object from t equals 0 to t equals 6 is 3.82 meters. So just to recap, displacement is the integral from a to b of the velocity function dt, and distance traveled is the integral from a to b of the absolute value of the velocity function dt. And this is a paper slide video made by Sujay Kestur, Furth and Girish Ganesh.